Welcome to this explainer. Okay, today we're looking at something that is literally shaking up the bleeding edge of the AI landscape. I'm talking about a brand new, massive release from Z.ai called GLM 5.2. If you've been following the rapid evolution of large language models, you've probably noticed the frontier has mostly been dominated by proprietary closed-door systems. Well, GLM 5.2 is stepping right into the ring as a heavyweight, pure open source challenger. We're going to break down exactly what this model is, look at the astonishing benchmarks it's hitting, and most importantly, explore how you can actually get your hands on it.
Let's start right here with a massive number, 753 billion. That is the sheer scale of GLM 5.2, 753 billion parameters. In the world of AI, parameters are essentially the synthetic synapses of the model, right? They represent its raw processing power, its reasoning depth, and its capacity to understand really complex patterns. Now, operating a model at this colossal scale is normally reserved for the absolute titans of the industry, running in massive locked-down server farms. But Z.ai has somehow managed to pack this staggering amount of architectural power into an open-source framework. No way, right? But they did it.
And this brilliantly illustrates our next staggering metric, a solid 1 million token context window. To put that into perspective, context window is basically the model's working memory. It's how much info it can keep in its head at any given moment. So 1 million tokens? That is roughly equivalent to handing the model an entire stack of thick reference books, full code bases, and historical data logs, and asking it to synthesize the whole shebang simultaneously without losing the plot. This completely sets up GLM 5.2's capacity for long-horizon tasks, meaning it can take on complex, multi-step engineering problems that would cause lesser models to just forget what they were doing halfway through. So here is our roadmap for the explainer today. First, we'll meet GLM 5.2. Second, we'll look at the 1 million token mind. Third, head-to-head benchmarks. Fourth, coding and agentic engineering. And finally, deployment and open access. We'll systematically break down the tech, the proof of its dominance, and exactly how to deploy it locally. Okay, let's dive into this. Section 1. Meet GLM 5.2, the pure open flagship.
GLM 5.2 is officially billed as Z.ai's latest flagship model, and it's specifically designed from the ground up for long-horizon tasks. But honestly, the most disruptive part of its identity is the license. It operates under a pure MIT open-source license. This means absolutely no regional limits, no restrictive corporate firewalls, just technical access without borders. In an era where top-tier AI is increasingly centralized and paywalled, this is a real David versus Goliath scenario. This model is giving the global developer community unrestricted access to a 753 billion parameter powerhouse, fundamentally challenging the closed ecosystems of the world's biggest tech companies.
Section 2. The 1 million token mind. Let's break down the architecture. Now, handling a library's worth of tokens requires incredible computational efficiency. If you try to just brute force that much context, your hardware is going to crash under the weight of the memory requirements. So the team at Z.ai had to fundamentally rethink the model's architecture. Their secret sauce? A brilliant design called index share. Think of it like a giant physical library. Normally, an AI model has to build a brand new card catalog for every single aisle it walks down, which takes an enormous amount of time and energy. Index share essentially allows the model's librarian to reuse the exact same catalog index across every 4 sparse attention layers, which is basically how the model decides what information to focus on. It shares the indexing work, completely skipping all those redundant calculations. Because of this index share breakthrough, the model reduces its per-token floating point operations, or flops, by an incredible 2.9 times when operating at that 1 million context length. That 2.9x reduction is exactly what makes such massive scale highly efficient and, actually usable in the real world. It proves we aren't just scaling up raw hardware power, we are scaling up the intelligence of the architecture itself. Let's move to and see how this builds on previous versions. GLM 5.2 introduces a vastly improved MTP layer for speculative decoding. Speculative decoding is basically the model guessing ahead to generate text faster. With this upgraded MTP layer, GLM 5.2 sees up to a 20% increased acceptance length over its predecessor. So the model's guesses are accurate much farther out, which significantly speeds up generation times. It's reading deep, but it's also writing really fast. Section 3. Head-to-head benchmarks. Proving dominance. Now, what's really interesting about this performance data is how it holds up when put in the ring with the best models on the planet. Look at the rigorous AME 2026 reasoning benchmark, which tests high-level mathematical reasoning. GLM 5.2 comes in with a score of 99.2, outright beating future state proprietary giants. It edges past GPT 5.5 at 98.3 and completely leaps over Claude Opus 4.8 at 95.7. For an open-weight, MIT-licensed model to dominate at the absolute frontier of math reasoning, well, that's a total watershed moment for the open-source community.
And the victories aren't just isolated to math. If we look at other rigorous categories, like the Agentic MCP Atlas public set, GLM 5.2 scores a 76.8, slightly edging out GPT 5.5's 75.3. On Humanities Last Exam, or HLE, with tools enabled, it scores 54.7, again beating GPT 5.5's 52.2. Now, okay, GPT 5.5 does take the win in the GPQA Diamond benchmark, scoring 93.6 to GLM 5.2's 91.2, but the overarching narrative is crystal clear. GLM 5.2 is trading blows with and frequently defeating the most advanced proprietary models out there across deep reasoning and agentic tasks.
Section 4. Coding and Agentic Engineering. Autonomous Software Creation. You might be wondering, how does a model that aces math tests perform when you ask it to autonomously write, test, and debug actual software? Well, to prove its capabilities, GLM 5.2 was subjected to the Deep Swede testing framework, and the conditions of this sandbox were intense. The model was given a 400K context window and a strict 2-hour timeout to solve complex software engineering problems. But here's the kicker. It was locked in an isolated container with only 2 CPUs, 8 gigabytes of RAM, and absolutely no internet access. It couldn't look up documentation. Actually, scratch that. It couldn't even search for answers if it wanted to. It had to rely entirely on its own internal reasoning to navigate the codebase and fix bugs. The results from these software engineering benchmarks are phenomenal. On the SWE Bench Pro score, Claude Opus 4.8 does take the top spot with a very strong 69.2. But look at second place. GLM 5.2 secures a 62.1, comfortably beating GPT 5.5's 58.6. It also outperformed DeepSeek V4 Pro here. This really cements GLM 5.2's role not just as a text generator, but as a truly elite coding agent, capable of autonomously engineering software at a professional level. So, the crucial point is how you actually interact with this capability. GLM 5.2 introduces what they call advanced coding with flexible effort, meaning as a developer, you aren't locked into one mode. You can actually scale the model's thinking effort based on the task at hand. Need a quick script? Dial back the effort for lightning speed, low latency generation. But if you have a massive, complex architecture bug to fix, you can crank that thinking effort up, allowing the model to spend more compute on deep reasoning and planning before it types a single line of code. It puts the control of performance versus latency directly in your hands, a real game changer. Section 5. Deployment and Open Access. Let's talk about running it locally.
The benchmarks are amazing, the architecture is revolutionary, but honestly, the most important takeaway for us is that you don't need API keys or corporate permission to use this. You have total access to run this 753 billion parameter beast locally. The steps a developer can take right now to spin this up are surprisingly simple. Step 1, just download the open weights directly from the ZAI.org repository on Hugging Face. Step 2, load the model using an inference engine like VLLM or SGLang. And step 3, serve it locally on your own hardware. No regional locks, no rate limits, just pure access to a frontier-class intelligence on your own machine.
Plus, ZAI has ensured deep and immediate integration with the open source ecosystem. Out of the box, GLM 5.2 supports an incredibly diverse list of popular frameworks. Whether you prefer SGLang, VLLM, the standard Hugging Face Transformers library, K-Transformers, or Unsloth for efficient deployment, GLM 5.2 is ready to go. It even supports deployment on the Ascend NPU platform. They've literally removed the friction of adopting a new model.
We've covered the massive scale, the highly efficient index share architecture, its dominance over proprietary models and intense reasoning benchmarks, and how easily you can deploy it today. So I want to leave you with this provocative thought. You now have technical access without borders. With a solid 1 million token working memory, elite autonomous software engineering capabilities, and frontier-level intelligence running securely and locally on your own hardware, what will you build first?